Okay, let's look at the second one. Second one has the 20, 15, and the 1/3, but it has minus and plus in it. So since there's no multiplying or dividing, we don't have to worry about doing that third rule. We go down to our fourth rule that says to add and subtract from left to right. Well, addition and subtraction are equal in dominance. In other words, you don't do one of the operations before you do the other. You just do them in the order that you come to them. So if we go from left to right, we would just do 20 subtract 15. And when we subtract 15 from 20, we're going to be left with a 5. So in other words, we're doing this step first. And then we have 5 plus 1/3. Well, if you think of that as adding a whole number to a fraction, we add our whole numbers together, we add our fractions together, so we just end up with 5 and 1/3 as our answer. Now you certainly could put 5 over 1 and do it as an improper fraction and come over and get a common denominator. What would happen if you did that is you'd come up with 16/3. In other words, if you did 5 over 1 plus 1 over 3 and work that out, and we'll go ahead and do it. The common denominator would be 3. So you'd multiply by 3, and get 15. And just copy your 1 up here because it already has the denominator of 3. So if you added those up, you would end up with 16/3, which divides out to be 5 and 1/3. So you'd get the same answer if you wanted to make both of those look like a fraction and find a common denominator, as you do by just saying 5 plus 1/3 is 5 and 1/3. If you understand doing it this way, it's certainly much quicker. Let's try another problem. This time we have some exponents, an exponent in problem 2. Okay, our problem is 8 plus 4 divided by 1 2/3 squared, subtract 5. So if we think about our rules for order, we still don't have any parentheses. All these parentheses are doing is telling us to square. So we still don't work within parentheses. But we can follow our next step, our second step, which says to do exponents. So we want to work with this 1 2/3, so we copy everything else down just as it is. 8 plus 4 divided by, and then we want to do the 1 2/3 squared. So I'm going to come over the side and do the 1 2/3 squared. Okay, to do that, I'm going to need to make it 5/3 and do 5/3 squared. So it means I'm going to have 5/3 twice. I'm going to multiply 5/3 by 5/3. And I'm going to come up with 25/9. So that's what my 1 2/3 squared would be. So I'd come back over here and write down my 25/9. That replaces my 1 2/3 squared, and then I'll write my minus 5. So now look at my problem and decide what I need to do next. Well, my rule tells me after I finish doing exponents, I multiply and divide from left to right. And I only have one of these in here, this division. So I need to do the 4 divided by the 25/9. I think I'll go ahead and do that in the problem since I've used up a space over here. So that would be 8 plus, and I'd want to make that 4 look like a fraction, so I'd write it 4 over 1. I'd change my division to multiplying, and I'd invert my divisor or my second fraction and make it 9/25, and then my minus 5 would still be here. Once I turned it into multiplying, I'd look and see if I could do any reducing. I don't see anything I can reduce, so I'd have 8 plus 36/25, because you multiply numerator by numerator and denominator by denominator, and then my minus 5. Now, we have a couple of choices here about what to do. We can either make everything improper and find common denominators, or we can change that 36/25 back to a mixed number. If we change it back to a mixed number, 25 will go into 36 one time, and we'd have 11 left over. So we'd have 1 and 11/25, subtract 5. So then, if we did our adding and subtracting from left to right, 8 plus 1 and 11/25 would give us 9 and 11/25, and then minus the 5. So in other words, I'm doing this operation. Now I'm down to the end and I'm ready to subtract, and I can just subtract my whole numbers and get 4 and 11/25. Now the reason I'm able to do that is if I put these under each other, what I'm doing is I'm saying 0 from 11/25 leaves 11/25, and 5 from 9 leaves 4. So my answer would be 4 and 11/25. Now the other choice here would be, as I said, you got ready to do this step where you want to add these two, to leave that as improper and think of this as 8/1 plus 36/25, and add them like they're improper fractions. Let's see if we have room to do that right here so I can show you. Our common denominator would be 25. So this would just be 36/25. Up here we'd have to multiply by 25. So I'd have to say 25 times 8. So I'd say 8 times 5 is 40. And carry my 4. 2 times 8 is 16, and 4 would be 20. So I'd end up with 200. So I'd have 200 plus 36, or 236/25. Okay, that's what I get when I finished adding the 8 and the 36/25. So then what I have to do, and I'm going to need to show you down here. In other words, what we just did is we had 8/1 plus 36/25, subtract 5. When we did this, by getting a common denominator over here, we came up with 236/25. And then we'd have to minus the 5. So if we were going to do it like improper fractions, we'd put a 1 under the 5 also and get a common denominator. So we come back over here and we take our 236/25 and our 5/1 and get a common denominator. So we'd use 25. We'd use 25 down here, so we'd say times 25 times 25, and that would give us 125. And we're subtracting now. So we'd say 5 from 6 leaves 1, 2 from 3 leaves 1, 1 from 2 leaves 1. So I'd end up with 111/25. So that would be my final answer over here, 111/25. And that would be fine. Or I could divide it out. If I divide it out, 25 ends up going into 111 4 times. 4 times 25 is 100, and you have 11/25 left over. And that's the answer we got up here when we kept everything as mixed numbers. 9 and 11/25 minus 5 gave us the 4 and 11/25. So you see that answer and this answer agree.